So in this video, we're going to talk about simplifying trigonometric expressions. And most of the things that we are going to use to simplify these trigonometric expressions are the following. So we're going to use what are called the reciprocal identities. And the reciprocal identities say that the secant of x is equal to 1 over the cosine of x, that the cosecant of x is 1 over the sine x, and that the cotangent of x is 1 over the tangent of x. Or they might use, so there's reciprocal identities, they might use the quotient identities. And the quotient identities say that the tangent of x is equal to the sine of x over the cosine of x. And that the cotangent of x is equal to the cosine of x over the sine of x. Or they might use the Pythagorean identities. And the Pythagorean identities, the first one says that sine squared theta plus cosine squared theta equals 1. And that's the main one that I remember. There are two other Pythagorean identities, and one of them you can get by taking the original equation, sine squared theta plus cosine squared theta equals 1, and dividing everything by sine squared. And remember that sine squared, when we put the little 2 up here, we're talking about really that means, if you were to write it, it means the sine of theta, that whole entire quantity squared. So sine squared theta over sine squared theta is 1. Cosine over sine is cotangent, so this is cotangent squared theta. And 1 over sine squared theta is cosecant squared theta. Oops. So that's the second Pythagorean identity. The third one is to start with sine squared theta plus cosine squared theta equals 1, and this time divide everything by cosine squared theta. And so in this case, sine squared theta over cosine squared theta is tangent squared theta. And cosine squared theta over cosine squared theta is 1, and 1 over cosine squared theta is secant squared theta. So you end up with this basic one, sine squared plus cosine squared equals 1. This one, 1 plus cotangent squared theta equals cosecant squared theta, and tangent squared theta plus 1 equals secant squared theta. And those are the 3 Pythagorean identities. So now we're going to use these to simplify. So, for example, simplify. We'll do a couple here. So the first one, secant x, cosine x. Well, secant x, remember, is 1 over cosine x. So I have 1 over cosine x times cosine x. And so the cosine x's would cancel each other out, and this is just going to be 1. So we'll do a couple more here. B, we'll have cosine of x, cosecant of x, all over the cotangent of x. So in this case, the first thing that I would do is I would rewrite cosecant in terms of sines or cosines. So cosecant of x, remember, is 1 over sine x. And that's all over cotangent x. And then on the top, I have cosine x over sine x. And on the bottom, I have cotangent of x. But remember, cosine over sine happens to actually be cotangent of x. So I have cotangent of x divided by cotangent of x. So this one also is 1. The answer to every single one of these problems is not 1. So we'll do another one here. So one more here. If I have well, we'll do two more actually. Cotangent of x times the secant of x. So here I would probably change everything into sines and cosines. So cotangent is cosine of x over sine of x. And secant is 1 over the cosine of x. So my cosines of x would cancel. So I get 1 over sine x. But 1 over sine x is cosecant of x. So my last one here that I'm going to do, so sine squared x minus cosine squared x sine squared x. So if you'll notice, the two terms here both have a sine squared x in them, so I'm going to factor that out. So this is going to be sine squared x times 1 minus cosine squared x. Oops, not beta. And if you remember, we had that Pythagorean identity that said sine squared x plus cosine squared x equals 1. So if I subtracted cosine squared x from both sides, I would have that sine squared x is 1 minus cosine squared x. And if you happen to notice, here we happen to have 1 minus cosine squared x. So I can replace that with sine squared x. So sine squared x times sine squared x. And so basically you're saying I have two sines and another two sines. So I end up having sine to the fourth of x. So all the problems in this section are going to use those reciprocal or quotient identities and the Pythagorean identities.